Welcome students. In the last video we were discuss about the introductory part of the chapter number first, that is the phase equilibrium. In that case we were discuss the what is mean by phase and what is the mean by equilibrium and how the equilibrium exists between the two or more than two phases like that. And after that we have discussed the importance of the phase equilibrium and we were cover all the important points related to the phase equilibrium concept. I hope all of you note down all these things related to the phase equilibrium concept. The students, as in the last video I will discuss about the example, that this kind of example, ice is converted into water molecules and this water get converted into what? Vapor state. Water get converted into vapor states. And as we know, in the universe there are three states of matter. First one is solid. This ice exists in solid. This water exists in a liquid state. Water exists in a liquid state and this vapors exist in a gas state. And this equilibrium sign indicates at a specific conditions this ice is equilibrium with water molecules and this water molecules is equilibrium with the vapor phase at a specific conditions. And that conditions specified by change in temperature, that means change in temperature. I am writing here change in temperature. If I change the temperature, this ice get converted into vapors, ice get converted into liquid state, that is in the water molecules, and this water molecules get converted into vapor state if suppose I am increasing the temperature. If I am decreasing the temperature, these vapors get converted into these gaseous vapors. This water molecules in the vapor state get converted into liquid molecules. And if when I am decreasing the temperature, then this what happens, this water molecules get converted into solid state. Okay, so this is the first conditions. Temperature increase, we can change the temperature, we can change the pressure. If I change the pressure, then also this three states get interconverted to each other. So this is the another factor. And third factor is compositions. Third factor is compositions, or we can say concentrations of this each constituent, that is the water molecules compositions. Okay, so the scientist name of scientist is Gibbs. Name of scientist is Gibbs. Studied 1876. Studied in 1876. Studied the heterogeneous equilibrium. Number of heterogeneous equilibrium. Number of heterogeneous equilibrium systems. Number of heterogeneous equilibrium systems. 1976, the scientist Gibbs studied the number of heterogeneous equilibrium systems, and he generalized the simple rule, and that simple rules we can say the rule is phase rule. That rule is known as a phase rule. Okay, see this in the universe matters exist in the three states, and these three states are interconvertible, and this interconversion of the states in the states of the matters is depends on the temperature, pressures and the concentrations or the compositions of the constituent molecules. Then these scientists in 1876, the scientist Gibbs is studied the number of heterogeneous equilibrium systems and generalized the simple rule, and that rule known as the phase rule. And this is very important. Phase rule is very important in the phase equilibrium concept. Phase equilibrium concept. So this is the our next topic, that is the phase rule. That is the phase rule. So we have to know what is the phase rule, general statement of the phase rule, and how to use these rules. So the next topic is phase rule. Phase rule, we can say this is also known as a Gibbs rule, and year of studied heterogeneous equilibrium systems 1876. Okay, he state this scientist, or the rule is mathematically, we can express these rules mathematically. F is equal to C minus capital P plus 2. This is the simple mathematical expressions of the phase rule. This is the very simple and very easy statement or easy equations. By using these equations, we can predict, we can write statement like that. Statement is also very important, but this, on the basis of these equations, we can easily write the statement of the rule. The statement of the rule is that F is the number of degree of freedom. So the number of degree of freedom, here we have denoted in the equations F. Number of degree of freedom is denoted by F. So we can say the number of degree of freedom of the system is related to the number of components, and this number of components is denoted by capital C. Number of component is denoted by capital C. Okay, number of component and phase, number of phase, and this capital P is denoted by phases. The phases can be denoted by capital P at equilibrium. This is the simple statement by using this mathematical equations. So you have to remember, for the exam point of view, you have to remember these equations, and on these equations or in this formula you can write the statement like that. And in this statement, this F indicates the number of degree of freedom, and this C indicates the number of component, and this P is number of P is what? Number of phases, and this plus 2 is taken here for the specific conditions. Here is the conditions, number of variables. We can say minimum number of variables, and variables means what? We can change the temperatures, the minimum number of variables, that means temperature, pressure, and concentrations. These are the variables. We can change one phase, interconvert to another state or another phase by changing the temperature, by changing the pressure. So 2 is the common for the this equilibrium system or any equilibrium systems. So this is the statement. On this statement we have to if suppose questions may ask like that, give the phase rule or give the statement of the phase rule. So your statements like that, and if you are forgetting this statement, if you are not remember this statement, then you should remember the equations. On these equations you can write like this, what number of degree of freedom of this system is related to the number of component and phases at equilibrium. This is this very simple statement and very easy statements and very easy to remember it. Okay, so but here what is mean by number of degree of freedom? This is another first questions. Second question is number of component, and third question is what is mean by phase, what is the definitions of phase, what is the definitions of C, and what is the definitions of F. So these three definitions are very important for the exam point of view. So we have to know the definitions of the degree of freedom, components and phases. So let us discuss one by one. What is mean by degree of freedom and what is mean by components, and how to calculate the number of component how many chemical components are present in the specific reactions or given equilibrium systems. Okay, first we will discuss the phase. Definitions is very important for the exam point of view, so you should remember these things. What is mean by phase? The definitions of phase is that a homogeneous, these definitions you have to write in your notebook. A homogeneous, physically distinct and mechanically separable part of the system, is known as phase. Full stop. This is the simple definitions of the phase. The word homogeneous, and this is physically distinct, and this is mechanically separable part, is very important word in the definitions of the phase. Homogeneous means what? Two solutions are completely mixed to each other. That solutions, we can say this is the homogeneous solution. For example, milk and water, milk plus water molecules, these are the homogeneous solutions because these milks are completely miscible, completely mixed into water molecules. So we can say this is the homogeneous solution. This is the very important. So the homogeneous, physically distinct means what? If the two systems are in equilibrium conditions and physically distinct, that means this is the water molecules, and this is the oil molecules, then we can say this is the heterogeneous solution. This is homogeneous solutions, and this is the heterogeneous solutions. Both are the solutions, but here milk and water molecules, homogeneous solutions form homogeneous solutions, and oil and water molecules form heterogeneous solutions. What is the difference between these two? This milk is completely mixed to water molecules, but in this heterogeneous solutions, this oil molecules is not mixed with water molecules. So we can say this is the heterogeneous solutions, and we can physically distinct. That means we can see this is the boundary surface between these two two solutions, that means oils and water molecules, there are one boundary solutions. So we can say this is the physically distinct, that means physically we can say this is the oil and this is the water molecules. And last one is what? Mechanically separable part. Mechanically separable part. If suppose this is the heterogeneous solutions, and these heterogeneous solutions, what? Oil and water molecules we have to separate mechanically. We have to separate mechanically. Mechanically separable part means what? Mechanically separate. Separations, we can say mechanically separation. If suppose I wanted to separate oil from water molecules or water from oil molecules, so I will can I separate this mechanically? Mechanically separable parts means what? We have to use this separating funnel. Separating funnel. Glassware, that is the funnel. Funnel is very common to you, but the such type of solutions we have to use this separating funnel, and this separating funnel is available in our laboratory. So we have to, if suppose I wanted to separate these oils from water molecules, we can I can use the separating funnel. Second thing, if suppose two solids are mixed to each other, if suppose two solids are mixed to each other, sugar and salt is there, so we can separate by hand, we can say hand picking of crystals. Hand picking of crystals, I can separate by hand the what? Sugar plus salt. These are the what? Both are solid, but salt's crystal size is very small and sugar crystal size are different than the salt. So I can separate by this sugar into water, from this mixture, sugar and salt by using my hand scheme, or we can say hand pickling of the crystal. This is the mechanically separable part. Next mechanically separable part is what? The filter, simple filter. We can filter the by using the funnel and filter papers. This is also what? Mechanically separable part. So heterogeneous system, just like that. If suppose I'm not like these oils and water molecule is there. If suppose I wanted to separate, here is some crystals, some organic compound or inorganic compound is here, and this is the water molecules. So this is also heterogeneous system of one system of this is also heterogeneous system. First one phase is liquid and another phase is what? Solid. So I wanted to separate this solid from liquid system, so I will use the simple filtration assembly to separate the solid molecules and separate the liquid molecules. These are the mechanically separable parts. So these are the definitions of the phase. First things, homogeneous solutions, that means homogeneous solutions. Physically distinct, that means there is one boundary surface between these two between these two solutions, and mechanically separable part of the system is known as a phase. Mechanical separations, if suppose I wanted to separate these heterogeneous systems by using separating funnel, by using hand picking of crystals, by using simple filtration assembly. So will I say this filtration as we can say distillation, fractional distillation, and some extraction. Will I say these are the mechanical separable part? No, because these fractional distillations or these extractions, these two types of separations requires temperature, specific temperature and pressure, and that's why we are changing the temperature and pressure. So we cannot say these are the mechanical separable part of the system. This fractional distillations and extractions of the some another extractions of the natural products and extractions of the oils and all these things are not involved in the mechanical separations, because this requires temperature and pressure. So we cannot say this fractional distillation is mechanical separation or this extraction is mechanical separations. Okay, so these mechanical separations means what? We don't require any kinds of temperature, or we don't change the temperature of the system and don't change the temperature of the temperature and pressure of the systems. So that systems or that separations we will say this is the mechanical separations. Okay, so this is the definitions of the what? Phase. Okay, and in the last video we were cover the number of examples of the how to predict the how many phases are exist in the given system, and how to predict the what how many pages are exist in the systems. Okay, so here I am taking a example, one example. Ice is in equilibrium with water, and last one is vapors. Okay, this ice is exist in the solid state, water is exist in the liquid state, and this vapor is exist in a gas state. So every state has a one or single phase. So solid, liquid, gas. So I can say this is the three-phase system. I can say this is the three-phase system. Okay, this is the three-phase system. If suppose I am taking another example, this is the first example, I can say this is the water system. This is the water system. Second, aqueous I am writing in short. Aqueous NaCl. Aqueous NaCl means what? NaCl, sodium chloride, is in water molecules. I am writing like that. NaCl is in equilibrium with water molecules. But as we know, these sodium chlorides are completely mixed to water molecules. As we know, this sodium chloride is completely mixed with water molecules. So this is homogeneous solutions, NaCl plus what? H2. This completely mixed to each other. This also exists in the solid state, this also exists in the liquid state, but this is form homogeneous solutions, and this we cannot say these are the physically distinct. So this has a what? One phase system. This has a one phase system, because the solutions are what? Homogeneous solution. The solutions are a homogeneous solution, no doubt. If suppose NaCl, sodium chloride, is not dissolved in water molecules, and I can see these are the sodium chloride and these are the water molecules, then I can say these are the two-phase system. But this aqueous NaCl, that means the sodium chlorides are completely soluble in water molecule, so they form homogeneous solutions. So only one layer only one solution, homogeneous solution, is observed to us, and these solutions are not physically distinct. So we can say this is the one phase system. This is the one phase system. Another example I am writing here: aqueous solutions of sugar. And another, this is also, we can say this is also one phase system. One phase system, that means the sugar molecules are completely mixed with water molecules. So we can say the solution form solutions are homogeneous solutions. they are not homogeneous, so physically distinct. So we can say these are the one phase system. This is the one phase system. Okay, so on the basis of this we can predict the how many phases are present in the given systems. So if suppose water system is given to you, so water system is what? Ice, water and vapors. These are the three states of matters, and this ice exists in the solid state, water exists in the liquid state, vapor exists in a gaseous state. So we can say this is the three phase system. Aqueous NaCl is given to you, aqueous NaCl is given to you, then we can say this is the what? One phase system, because what? This is the form homogeneous solution. Sodium chloride is soluble in water molecules, so we can say this form homogeneous solution. Homogeneous solutions always have a single phase, like this, like aqueous NaCl. This aqueous sugar is also what? One phase system. Okay, these are the related to the what? Phase. Now another thing is what? In the phase rule, that is the component, Another thing is what? In the phase rule, component, and we have to know the definitions of components. So second thing, components is denoted by capital C, not a small c. I am writing here capital C, not a small c. The definitions of component is what? The minimum number of independent chemical constituents necessary to describe the system, to describe the system, describe the compositions, describe the compositions of each phase of the system it's called the it's called components. We can say these are the components. Okay, so what is the definitions? The minimum number of independent chemical constituents which are necessary to describe the compositions of the each phase of this system is called one component. For example, I am writing again and again this example: ice plus water is in equilibrium with vapor state. This ice exists in solid state, water exists in liquid state, and vapor exists in a gaseous state. So in this system, in this water system, number of phases are 3. But how many components is there? The definition itself indicates us the minimum number of independent chemical constituents which are necessary to express or which are necessary to describe the compositions of the each phase. In this was ice. In this ice is water molecules. This is also water molecules. minimum number of independent chemical constituents. This I is made from water molecules. This water molecule is made up from this H2O, and this vapor molecule is also made from what? H2O. So how many number of chemical components? Only one number of chemical components. So we can say this system, water system, has one component. This water system has one component. Why one component? Because this ice made from what? H2O. Water made from what? H2O. And this vapor made from what? H2O. Same chemical component is present in the each phase. That's why we can say minimum number of independent chemical constituents which are used to describe the chemical compositions of the each phase. Chemical compositions of the each phase of the systems, we can say, in that system, that minimum number we can say the components. So here is what? One component systems, and phases are 3, So next example, we will see next example. Number of C is what? 1. You have to write all these things in your notebook. So this is the first example. Next example is what? Aqueous NaCl solutions. Aqueous NaCl solutions. So I am writing these equations. NaCl is in equilibrium with water molecule. Because of this sodium chloride is completely mixed into water molecules. The phase of the formed solution is what? Homogeneous solution. So we can say the phase of this system is one phase system, and number of component is what? This NaCl are different and this H2 are different. We can say theoretically this NaCl is solid form and this is liquid form, but NaCls are completely mixed or completely soluble in water molecules. So this NaCl are different and this H2O are different. So the chemical component in this system are 2. The chemical component in these systems are 2. Okay. Another example is there. I am writing here calcium carbonate plus, this is the reactions is written to you like that, calcium oxide plus carbon dioxide. This is gaseous state, this is solid state, and this also solid state. So the number of phases in this state, number of phases in this system are what? How many number of phases? This every solid state, every solid crystals has a single phase. So here are two solid compound is here, solid is two chemical component is here. So we can say first, second, and gases is third. So number of phases are what? How many number of phases? 3. And number of chemical component, minimum number of chemical component is what? 2. Number of minimum chemical components, because calcium carbonate and calcium oxides are minimum number to describe the compositions of each phase of the system, each phase. If suppose this is the solid, this is the solid, so I am writing here like that, calcium chloride is in equilibrium with calcium. This is the two chemical components. This two chemical components are what? Necessary, or we can say these are the sufficient to describe the compositions of each phase. These are also solid, these are also solid. If suppose I am writing like that, is in equilibrium with CO2 liquid, these two phases, this is solid phase and this is liquid phase. So these two chemicals are sufficient to describe the compositions of each phase, that means solid phase and liquid phase. So this is the two phase. We can find out, we can say theoretically this reactions has a what number of phases 3 and components is 2. This we can say this theoretically by calculating, also by calculations we can calculate, we can also calculate the number of component 2, but the calculations are much more complicated. Because of that I am not writing all these things. Okay, so this all these thing about the number of chemical component. And third and last one is terminology used in the phase equilibrium or phase rule is degree of freedom. Degree of freedom, and degree of freedom is third degree of freedom. Degree of freedom denoted by capital F, Okay, degree of freedom, the definitions of degree of freedom is like that: the minimum number of intensive. This word is very important. You have been heard about the intensive word, intensive variable. I will explain what is meant by intensive. Intensive variables which must be fixed, in order to define the remaining. This is the definitions, and definition is very important for the exam point of view. So you have to write these definitions in your notebook. Intensive variables of the system is called degree of freedom. Degree of freedom. Okay, this is the simple definitions of the degree of freedom. The minimum number of intensive variable. The intensive word means what? Intensive property means what? That property which does not depend on the number, how much matter is exist in the system or how much matter is present in the system. That means do not depend on the matter of the systems. In this phase equilibrium is totally depends on the matters, we can say these are the intensive variable. Minimum number of intensive variables means what? Here in the phase equilibrium we were discuss about only 3 variables. First one is temperature, second one is pressure, and third one is compositions or concentrations. These are the 3 variables, and all these are the what? All these are the intensive variables. Intensive variables means what? The boiling point of, suppose I am taking another example. If suppose I am taking water molecule, 50 ml is in this water molecules, 50 ml of water molecules in this beaker, 50 ml. Another beaker is taken, and in this beakers I will take the 100 ml same water molecules. When I check the boiling point of 15 ml water molecules, and when I check the 100 ml boiling point of 100 ml of water molecules, the boiling point of the 50 ml water molecules and 100 ml water molecules are the same, are the same. That means how much quantity of water molecule is present in the system, or this that property, we can say that property. Boiling point is what? The intensive property. Boiling point is not depend on the how much quantity of water molecule is present in this beaker. So this is the intensive property. Melting point is also same like that. Melting point is what? Melting point is what? If suppose I am taking any solid molecules, if I is taking the another ice is taken in this. So 50 gram ice taken in one beaker and 100 gram ice taken in another beaker, the melting point, we can say the melting point of this ice is same, like 50 gram and 100 gram. That means these properties, melting point is a intensive property. That means what? The intensive property is what? Intensive property is not depends on the how much quantity of matters exist or matters are present in the system. That property we can say intensive variable. So the degree of freedom is, definitions of degree of freedom is what? The minimum number of intensive variables which must be fixed in order to define the remaining intensive variables of the system. It is called degree of freedom. Degree of freedoms. So this is all these things, these are the phase rule. So simple equation phase rule is given to you. The phase rule, degree of freedom is related to the number of components and number of phases plus 2. This is the what? Phase rule, and this phase rule is totally depend, this phase equilibrium concept is totally depends on this phase rule, and on these phase rules we can predict the at what conditions or at what temperature the two or more than two phases are in equilibrium, or what change in pressure. If suppose I am changing the pressure, what will happens, we can specify by using these equations. So importance already I have covered in the last video. So this is the degree of freedoms. So this is the F upon F is equal to C minus P plus 2. 2 is what here? This, because of this temperature and pressure and compositions. Any two variables taking this equation. Okay, if suppose I am taking pressure and composition fixed, then I am taking the 2, temperature and pressure, then also 2. So all these things are related to phase equilibrium and phase rule. If suppose if any system phase is equal to, degree of freedom is equal to what? 0, then we can say this is the non-variant system. We can say degree of freedom is 0, then we can say this system are non-variant. If suppose F is equal to 1, then we can say monovariant system. Example we will see in the next video or next lecture. Monovariant systems, that system we can say F is equal to 1, that is monovariant systems. If suppose F is equal to 2, we can say this is the bivariant system. Like that. Okay, so all these things are related to the phase rules. I have covered all the points related to introductions of the phase equilibrium in the last video, and in this video we have covered the phase rules, statement of the phase rule, equation of the phase rules, and each component, we can say each symbol, that is F is what? Degree of freedom, C is what? Components, and P is what? Phases. The definitions of phase, chemical components, and degree of freedoms we have covered in this video, and I hope all of you understand all these things and note down in your notebook these points and related to equations, related examples in your notebook. And If you have any query related to the phase rules or any phase equilibrium, you can contact me. Thank you very much.